All right, so good evening, everyone. I welcome you all to this session. Uh, so, today we will be studying how we will apply gradient descent in linear regression. Okay, we'll try to see the derivation of it, and also we'll see the coding part of it. Okay, so let's start. All right. Okay, so yesterday we saw like gradient descent algorithm. So, can any one of you tell me what are the key steps that we do in gradient descent? What do we do in that? Yeah, anyone, like what are the main steps that we do in gradient descent? So, all right, no problem. We'll just start the session. So, before moving forward, I would like to tell you some terms. Okay, I would like to tell you some terms. Okay, so the first term that I want that you should know, that is known as the cost function. So basically, like, what is a cost function? Okay, so it is a function, okay, that measures the performance of a machine learning model. Okay, so like this is the definition of cost function. uh, Basically, like, what happens yesterday, what we did, we have the input that was x, we had the input that was y. Okay, it was basically like this. Now I had one variable that was known as the weight. Okay, I initialized with any value. All right, then what I did, I calculated the error. Okay, I calculated the error. So how did I calculate? I calculate y minus w into x whole square. All right, so this was my error function. Okay, so what I am doing over here, I want this to be as minimum as possible. Okay, I want this to be as minimum as possible. So this thing, okay, this thing is known as the cost function. Okay, so this cost function, okay, will be used for uh, like measuring the performance of any machine learning model. So the formula, okay, the cost function will vary, okay, as per the learning algorithm that we are using. Okay, so it, like, this was the case in which I had only one okay, one number. Okay, one number. So in this case, this was the like cost function that I used. All right, so yesterday I was using the term error. I'm trying to reduce the error. Okay, uh, like, we can also say that we are trying to reduce the cost function. Okay, so just remember this term, cost function. Okay, and let's see some other things. Now suppose we have a cost function. Okay, cost function, it is basically like this. Okay, it is basically like this. All right, so what happens that okay, what happens, suppose this is my cost function, and this is the point. Okay, this is the point that I want to reach. Okay, this is the point that I want to reach. Why I want to reach this point? Yeah, please tell why I want that I should come to this point. Okay, so this is my cost function, cost function. Okay, so this is the cost, and this is the um, weight, you can say. Okay, weight, you can say. So like, why I want to come over here? Okay, I want to come over here because here the cost is minimum. Okay, I want to minimize the cost. Okay, so this is my end goal. So what will happen, that I will start at some point. I'll start at this point. Okay, then I'll check the slope. Okay, using the gradient descent, I'll try to move forward. Using the gradient descent, I'll try to move forward, and eventually I will be able to reach this place. But sometimes what happens that okay, so the lowest point, okay, the lowest cost that we can have in a cost function. Okay, uh, this will be called as my global minima. Okay, so just remember the terms that are there, no? Global minima. All right. Okay, it is that point, okay, where my cost is minimum. Okay. Okay, it is the value of w. Okay, it is the value of w at which the cost is minimum. Okay, so this will be known as the global minima that we have. Now there is another term which is known as local minima. Okay, so if we talk about this portion only, if we talk about this portion only, then the local minima for this will be this. Okay, the minimum point in this part of the curve is this. Okay, now if we consider this part, the minimum point is this. All right, if you consider this part, the minimum point is this. Okay, so these points, okay, these points are known as local minima. Okay, okay, so if we talk about a part of a curve, okay, where it is at its lowest point. Okay, so that point will be known as the local minima. Okay, so just uh, remember these terms, local minima and global minima. Now what happens that basically the error function that we were using yesterday, so that was pretty straightforward. Okay, there was nothing to do. it has to it has to, okay, come like this. Simply it has to come like this, so there was no problem in that. Also uh, also like, but these cost function can be very complex. Okay, so these cost function can be like this also. Okay, these cost function can be like this also. Now my learning algorithm would be here. Okay, I would be here. Now algorithm will tell me that move in this direction. Okay, it will tell me move in this direction. It will tell me move in this direction. It will tell me move in this direction. Okay, so what will happen, this, okay, this algorithm will now be stuck over here. Okay, why this will be stuck over here? Because it will see that if I'm moving here, then the cost is increasing, and if I'm moving here, then also cost is increasing. Then why should I move in these directions? But okay, but is this point the global minima? Is this the global minima?
No, no, sir.
It's not the global
No.
minima, no? So this is not the global minima. Okay, this is the local minima that we have. So like, what will this function do? How will it come over here? Okay, so like, for this we use some other technique. Okay, we use some other technique. That technique is like called as momentum. So we'll not be discussing that, but I just wanted to tell you that what kind of problems that can occur, okay, when I'm trying to reach my global minima. So in this case, what will happen, that I will choose a value, okay, in such a way that it would be able to jump it would be able to make a jump over here. Okay, I need to choose such a value in which it can jump over here, and if it comes over here, then it will be able to converge. Okay, it will be able to converge. Like the meaning of converge. The meaning of converge is that suppose my cost is like first 100, then it is 80, then it is 20, that is 10, 5. Okay, so what is happening, that the cost is reducing. Okay, with every iteration cost is reducing, so that thing is known as convergence. Okay, that term, the term that we use for this is convergence, that my algorithm is being converged. Okay, my algorithm is converging. Okay, the cost is reducing. Okay, and like if the cost, like with every iterations go like this, 1, then 120, then 140, 160, 150. Okay, so here my algorithm is not converging. Okay, okay, like the thing is that the meaning of convergence, okay, the actual meaning is that if my like cost don't change after certain number of iterations. Okay, after certain number of iterations, if the cost doesn't change. Okay, why will the cost not change? Like if I have gone to this point, why will the cost not change in the other iterations?
because it will be the minimum.
Yeah, it has already reached the minimum, no? Okay, so if with every iteration the cost is not changing, that means my algorithm has converged. Okay, it has come to a conclusion. Okay, but if it is increasing, then it will say that it has not converged. Okay, it is not converging. So like, so this is the term. Okay, so just become familiar with these terms: local minima and global minima, and converge. Okay, when will we say my algorithm is converging? Okay, so yesterday I was using a term. Okay, that was known as learning rate. Okay, that was known as learning rate. So how I was using this, uh, I was using like this, uh, y minus, okay, sorry, the weight equation that I was using, weight weight equal to, okay, w minus learning rate into dw. Okay, so this dw is the slope. Okay, that I was calculating. Okay, so now let's see what is the role of this learning rate over here. Now what happens is that suppose my error function is like this. Okay, my error function is like this. 1 second, I'll draw this again. My error function is like this. Now, like, what will happen, you see that the slope over here is very high. Slope over here is very high, so what will happen, that it will move in this direction. Okay, it will move in this direction, and if it is over here, then it will move in this direction. Okay, now where will the problem come? Sometimes what will happen, that the slope value is like, suppose if I don't use my learning rate over here. Okay, let's see an example. If I don't have learning rate over here, now what will happen, that the slope value will be so much high. Okay, that the increase in the weight, okay, so this is my weight and this is my error. Okay, so the updation of my w, the new w that I will get, will be so much that it will jump over here. Okay, it will jump over here. Now again what will happen, here it will see that I need to move in this direction. Okay, so here also you can see that the slope is very high. So the slope, okay, so what it will do, it will decrease the value of w by so much value that that again it will come back to like this point. Okay, now again it will see that the slope is very high, I need to take a longer jump. So again it will come like this. So in this way what will happen, that it will not be able to come to this minimum point. Okay, minima we can say. Okay. So can you tell me what can be the solution? What is the problem over here? Why it is not coming to the minimum? Why it is not coming to the minimum? Like any guess why it is not coming to the minimum? It is making a jump. Now again it is making a jump. Then again it is making a jump. Why it is not coming to the minima? Like what is the problem over here? What, like what is the problem over here? Okay, so the step, okay, step, or you can say the jump that it is taking, that is too large. Okay, the jump that it is taking, it is too large. What we need to do, we need to reduce that jump. We need to reduce that jump. Okay, so that jump, okay, that jump will be controlled by this learning rate parameter. Okay, now what will happen, I'll reduce my learning rate. Okay, so what will happen, that it will come like this now. Okay, it will come like this. Okay, so in this way it will come to the global minima. Okay, but if I set my learning rate to be large, okay, then what will be the problem? Then it will again do like this. It will jump, take a big jump, then again it will take a big jump, it will again take a big jump. Okay, so it will not be able to come to the minima. Okay, if I took learning rate to be very large, if learning rate is large. Okay, if learning rate is large, then this will be the problem. What will happen if learning rate is low? Can anyone tell me what will happen if learning rate is low?
It will take more time to reach the minimum point.
Correct.
The more
Mm-hmm. Okay, so we will say that the number of iterations, okay, number of iterations, okay, to reach okay, global minima will be very high. Okay, will be very high if the learning rate is low. Okay, I'm sorry that I have written like so far away from this, but just okay, just see that this will be the problem. Okay, so if learning rate is low, then it will do like this. Slowly slowly it will come, slowly slowly, slowly slowly. Okay, so this I don't want. Okay, so what we need to do, we need to set learning rate at such a, okay, value, so that my okay, uh, so that I can come to the minima. Okay, in such a way that like I don't miss the local minima. Okay, the first thing is this, so that I don't miss this, sorry, this global minima. Okay, and I also, like, the number of iterations should not be like very large enough. Okay, so this learning rate like will generally depend on the problem that we have. So basically learning rate that we set is generally this 0.01. Okay, we generally set the learning rate to be 0.01. Okay, but this thing can change as per the, like, the problem that we are solving. Okay, so like this was about learning rate. So like yesterday also you would be seeing that if we increase the learning rate, then like the number of iterations that it is taking, okay, to come to the minimum will be uh, like large. Okay, so okay, so we'll also see the coding example of this. All right, now like we'll talk about this linear regression. Okay, okay, so first we will talk about simple linear regression. Okay, so in simple linear regression we have x and we have y. Okay, it is like pretty simple. And what do we find over here? We we find a equation like this. Okay, y predicted, we find the y predicted using this line that we have. Okay, so like what is my goal of linear regression? Like what is the thing that I want to find in linear regression? Like if I talk about this equation, which things are
To
unknown
find
to me?
the
Huh?
M and C. M and C.
M and C we need to find, no? Yeah, correct. M and C we need to find. Okay, so that is my goal in this. Now let's see the cost. Okay, the cost metric that we will use over here. Okay, that will be my mean square error. Okay, the mean square error. So the formula of mean square error is summation y minus y predicted. Okay, so this is why I'll write. Okay, whole square I equal to 1 to n, 1 upon n. Okay, so this is the cost that I will be uh, this is the cost function that I have. Okay, so my goal will be to reduce. Okay, reduce this cost. Okay, my goal is to reduce this cost. So I need to find those value of m and c, okay, for which the cost is at its minimum. Now can you tell me about this cost function? Like will it be a 2D curve or will it be a 3D curve? Like if we see over here, no, when our example was simple enough, like what which curve does it represents? Okay, so it represents a parabola. Okay, it represents a parabola. So what we need to find? We need to find the w, and we need to find this w. Okay, this was our goal. Now in this, what is happening? We have to find two values, m and c. Okay, so what will I do? I will write like this: yi minus the value of. Okay, I'll write the value of this y predicted. Okay, so I'll write like this: m xi plus c. Okay, why did I write m of xi? Why not mx plus c? Why did I write xi? Yeah, come on, like okay, when I'm talking about a particular row, na, a particular value, okay, particular value. Okay? Xi means the x1, then this is x2 second value, then it is x3. Okay, so that's why I have written this xi over here. So my goal is to reduce this mean square error. All right, now now what will happen, that I have two unknowns, that is m and c. I have two unknowns over here. So uh, this cost function, okay, this cost function will basically look like this. Let me show you. See, there will be three things over here. Okay, okay, let's see. One will be my m, other will be c, and in third dimension I'll have my mean square error. Okay, so these things will go in three dimension, and the thing that it will form, okay, will basically like look like this. Okay, it will be in 3D curve. Okay, so like if you can imagine, okay, you can imagine a cloth. Okay, there is a cloth, and if you put something in the cloth, okay, so then they okay, if you put a like stone in the cloth, okay, so there will be a depression created, no? there will be a depression created, so that kind of curve it will form. Like I'll show you what curve it will form. So like this is the curve, this is the curve. Okay, this is the curve it will form. So you can see that theta 1 and theta naught, it is referring to my m and c value. Okay, m and c value, and this axis, it is referring to the cost function or the mean square error that we have. Okay, so okay, so like this is the way like this cost function will look. So now what will I do? I will find, okay, I will do some calculations on this cost function so that the cost is reduced, and I'll apply the gradient descent on this. Okay, I'll apply the gradient descent on this. So can you tell me what values will be updated after each iteration? Which values will be updated? Yeah, please tell what values will be updated after each iteration. Like I need to find the appropriate m and c, no? Okay, so I need to change, okay, I need to change the value of m and I need to change the value of c. Okay, so what will I do? Okay, I'll find the gradient. Okay, gradient with respect to that particular variable that I have. Okay, so like what will happen, that I will write like this: m equal to m minus slope. Okay, this was my equation, slope into learning rate. This was my value, and also we'll have for c also we'll be updating it, slope into learning rate. Okay, so learning rate will be same for both of them. Okay, the only value, only thing that it will change will be the slope. Okay, now can you tell me what will be this slope? Like can you tell me that will these both the slopes will be same or will they be different? Okay, so I'll call this slope of m and I'll call this slope of c. Okay, so let's find the slope of m. Okay, slope of m, so slope of m I'll write like this: del of mean square error, okay, divided by m. Are you aware about this partial derivative, like what we do in partial derivative? Yeah, like have you studied partial derivative? Okay, so like what happens in partial derivative, basically it's like this. Like suppose we have x plus z. Okay, we have x plus z, we have two variables in a equation. Okay, so if I want to find the partial derivative with respect to x, then what will happen, I'll consider the other variable as constant. Okay, so the differentiation of this would be like, suppose it is x square. Okay, so the differentiation would be 2x. Okay, because z will be considered as a constant. Okay, and if I calculate dy by dz, what will come? What will come if I calculate del y by del z?
X square.
X square.
So
Correct.
1.
Yeah, it will come 1, no? Like x square is will be considered constant, no? I told you, no? So the differentiation of constant will be 0. Okay, sir, is it clear?
Yes.
No? So differentiation of z will be, with respect to z will be 1. Okay, so that is the same thing we will be doing over here. Okay, now just observe. Okay, just observe how will I calculate the derivation. Okay, let's see. I'll find del msc by del m. Okay, so what will happen, it will be 2 upon n. Okay, summation, I'm not writing I equal to 1 to n. Okay, just mark it like it is understood, minus sum of xi plus c. Okay, so we'll differentiate first this, like uh, okay, this x square term. Okay, so it will be 2 into this whole term. Then we'll find the differentiation, okay, of the inner term. So what will be the differentiation of the inner term with respect to m? Yeah, come on, like differentiation of inner term.
Minus xi.
Minus xi. Okay, okay, because like this will be constant, it will become 0, and differentiation of m will be 1, and only this will be left. Okay, so this will be my del msc by del m. Now I'll calculate del msc by del c. What will be the value of this? Yi minus m of xi plus c. Okay, and what will come over here? What will be the derivative with respect to c of this part?
-1.
Correct. -1. Okay, so these are the two terms that we got. Now I'll substitute these terms. Okay, so this slope is this. Okay, this slope is this, and this slope is this. Okay, so let's see, like what will be our equation. M equal to m minus, okay, 2 by n summation yi minus, I'll write it in shortcut. Okay, y predict, I'm like, for this I'm using y predict. Okay, into negative of xi. Correct, negative of xi. I can move this sign to this, okay, in the forward direction. Then negative negative will become positive. Okay, and same thing I'll do for the c. C equal to c minus 2 by n summation y I minus yp whole square. Okay, -1 is there. Okay, this -1 will come in the front and it will become plus. Okay, so these will be my like the update equation. Okay, these will be update equation. So in this way we will be updating the m value and c value. Okay, so like sometimes what will happen, that this term, okay, this term would be minus over here. If this is minus, then it will be always minus xi. So don't get confused why he has written plus, why he has written minus. If it is -1 over here, then this here he will be using a -1 value. Okay, I will show you this thing in code also. Okay, same equation I'll use, and okay, I'll find the all the weights. Okay, so these are the things that we will find. This will be my update. Now again, with these new weights I'll find the cost. Okay, with these new weights I'll find the cost. Again I'll update the weights. So this thing will keep on going. Okay, and will keep on going until for a particular number of iterations. Okay, which I will decide for myself. Okay, now like one more thing I'll tell you, that like first thing is okay, if we talk in terms of simple linear regression. Okay, simple linear regression, uh, like what will happen, that I have my x and y. Okay, now suppose my x is 1 2 3, y is 2 5 6. Okay, it is like this. Now what will happen, that my, okay, what I did, I created an array. Okay, np dot np dot array, I'll write np dot array, I'll write 1 2 3. Okay, so can you tell me what will be the shape of this What will be the shape of this y? Sorry, this will be x. What will be the shape of this?
1 cross 3.
1 cross 1 cross 3. No, it will not be this. See, why it will not be this? Like, okay, so here we have, like, what does this represents? Okay, this represents the number of rows that we have. This represents the number of columns that we have. Okay, in a 2D matrix, this represents the number of rows and this represents the number of columns that we have. Now, like, okay, now, and this thing will be applicable for a 2D matrix only. Okay, the rows and columns, this will be applicable for a 2D matrix only. So if you will check the shape of this x, no, it will only show you 3 comma, not 3 comma 1. Okay, because it is a 1D array. For 1D array, we will not have 1 into 3. Okay, so what I will be doing, okay, I need to like convert this like this. Okay, 1 2 3. Okay, so that its dimension become 3 cross 1. Okay, so in order to change this into like this, okay, into a 2D matrix, no, so that its dimension become like this, so what will happen that I need to, like, I need to make a, like, list inside a list. Okay, in this way. Now this will have okay, now this will have dimension 3 cross 1. What is the meaning of this? We have 3 rows, 1 2 3, and we have 1 column, only 1 column. Okay, so how do I change this? Okay, from this to this. Okay, so we will write like this. We x of, we'll be taking all the values of x, and np dot new axis we will use. Okay, we'll be using this thing in our code, np dot new axis. What it will do, it will convert this 1 2 3 into a 2D matrix, and that matrix will be like this. Okay, so what will be the index of this? What will be the index of this? 1. Come on, like, what will be the index of this 1?
0.
Only 0.
0 0.
Yeah, 0 0, no, because it is a 2D matrix, no. And for this 2.
So 0 1.
Why 0 1?
It is the 0th row and the first
No,
column.
this is not the 0th row. This is the first. See, when we were talking about the 2D array, okay, then what happened? That first I need to define the index of the array in which I am going. Okay, so the index of this array is 2. Sorry, 1. Okay, index of this array is 1, and the index of this 2 within this array is 0. Okay, same will go with goes with the 3 also. The index of 3 will be 2. Okay, so this array I'm talking. Okay, first we access the array, then we access the values inside the array. So then I'll write 2 0. Okay, now if I write like this, 1 2 3 4 5, 6. Okay. So what will be the dimension of this matrix? What will be the dimension? See,
2-dimensional.
this, okay, this actually it is like this. Okay. I need to think this matrix in this way only. Okay, but in reality, in the computer, it will be stored in this way. Now tell, what will be the dimension? Yeah, please tell. What will be the dimension?
2-dimensional.
2 dimension. And what will be the values of the rows and columns? How many rows and columns we have?
3 rows
Mm-hmm.
and 2 columns.
Correct? No? Now I want to access 4. How will I access this 4 value? Yeah, what will be the index? Suppose this is A. I need to access 4. First, I'll go to the that particular array. So what is the index of the array?
1.
And the value
1.
1 1. Okay, so like this is the index 0 1 2. This will refer to the array, and this will be 0 comma 1. Okay, so if I'll write 1 1, then it will become like this. Just give me 1 second. Hello, am I audible to you? Hello.
Yeah, yes. Sir.
Okay. Because there has been a power cut on my side, so that's why. Just give me 1 second. All right. Okay, so like just understand the concept of this thing. Okay, these two, like this thing I'll be using in the code. Okay, so that's why like you may get confused. Okay, because here we are talking about the simple linear regression, so I will be using a 1D array for that. Okay, but when I will go to the multiple linear regression, then what I will be doing that for y. Okay, for y. Okay, first I will store it in a 1D array, then I will convert it into a 2D array using this okay, using this. So that's why I wanted you to be like familiar with this thing. Okay, now let's go to the code part. Okay, now let's go to the code part, and we'll see. Sorry, there are so many tabs open. Okay, so like this is the algorithm gradient descent for simple linear regression. Okay, so like I have set my learning rate to be this value, and iterations means the number of iterations that I will be taking. Okay, the number of times I will be, okay, updating my weights. Okay, the meaning of iteration is this. N equal to 10 means that I'm taking like okay, the number of values that I'm taking. Okay, so here what I am doing, I'm creating an array from 1 to 5 using this command. Okay, and this why I have taken randomly. Okay, so and I have initialized my weight and bias to be 0. Okay, uh, like the example that I shown you, the example that I've shown you, what I'm doing, I'm saying this m as my weight, okay, and this thing as my bias. Okay, so like that's why I have used this term over here. Now what I am doing, okay, see, like this is the equation I'm using for finding the cost. Okay, see, y minus y predict, I'm squaring all the terms, then I'm doing a summation of all these terms. Okay, so this will be my cost. And how I'm doing the prediction is x into mx plus c we were using now. So m I'm calling it as weight and c I'm calling it as bias. Okay, so that will be my prediction. Okay, and this is my cost. Okay, like this, what I'm doing, I'm like saving all the cost in a array that is known as a cost. Okay, now what I have done, I have found the dw. Okay, del w. So like this is the same thing that I shown you. Okay, the difference between the derivative of this weight or the m that I was using was that we need to multiply this y minus y predict with the input, with the x value. Okay, I guess see, this x I was multiplying with the x now, so same thing I'm doing over here. Okay, so I'm multiplying with x and doing the summation and then doing this, and for my bias this will be my derivative. Okay, and I'm not multiplying with x, just okay, remember these this is the difference between these two. Okay, now what I'm doing, I'm updating the weights and bias. So see, I'm updating my weight and I'm updating my bias. So that is the same equation that I have told you. Okay, weight equal to weight minus slope into learning rate, bias equal to bias minus bias into learning rate. Okay, so what I will do, I will run these for 1,000 times. Okay, and then I will plot, okay, the cost. Okay, the cost or error that we are seeing. Okay, and we'll see that how will this curve turn out to be. Okay, so like this was the curve that came. Now see like what is happening, that okay, here what has happened, that the slope was very high. Okay, if you so see over here, the slope is very high, then it will take a quick jump. Okay, it will take a quick jump, and it will okay, here you can see that from 0 to 200 it is coming down very quickly. Okay, but after 200 to 1000 it is like decreasing very slowly. Okay, so can you tell me why from 200 to 1000 it is decreasing slowly? Why it is not decreasing slowly, like
So the slope is
fast?
very less.
Huh?
Slope is very less.
Yeah, correct.
Yeah.
Yeah, correct. Okay, so slope is very less, that's why it is reducing very slowly. Okay, now let's see, suppose I did some modification in my learning rate. Okay, now what will happen? Okay, I'm doing some modification and let's see. Okay, what will be, see, okay, earlier it was coming down, okay, near to this 200. Okay, when I increased my learning rate, okay, then you can see that it is coming down like much fast. Okay, so now suppose I increase it like more. Okay, I'm multiplying it by 10. Now let's see what will, now see, it is coming to the zero value in like we can say up to like 10-20, in 10-20 iteration only the error is coming near to zero. Okay, so you can see that learning rate is like what learning rate is doing. Okay, it is helping to converge. Okay, to converge quickly, but if I increase my learning rate to be very high, then what will happen? See, you're seeing what is happening, the error is going up. Okay, so that's why I told you that we cannot set learning rate to be very high, we cannot set it to be very low. Suppose I set it to be very low value I'll set. Okay, so this is a very low value. Let's see what will happen. See how slowly it is coming. Gradually it is coming. And when the iteration is in the 1000 iteration, I'm getting an error of 55. And earlier you were seeing that it was coming down to 0. Okay, when the learning rate was high. So what will I do? The learning rate value, like basically 0.01 we can use. So that is the ideal value. So you can see that it is coming down very quickly. But here the slope is very less. That's why it will not come down very quickly. Okay. So that is the way this linear regression, okay, simple linear regression works. Now I will tell you some other thing. Like we'll also see the final weights and the bias that we got. Okay, the final prediction I'll make, and you can see that the prediction and the actual. I'll calculate this again. See, this is the actual, this is the predicted, this is the actual, this is the predicted. So you can see it is very near, the prediction is very near to the actual values. And if I see the curve, you can see that it is following a linear curve. So here what happened, that the data was like linear enough, so that's why like it was able to, okay, come down to a zero error very quickly. But if the relationship is not linear, then it will have some problem, okay, converging. Okay, now let's see for multiple linear regression. Okay, let's see my gradient descent algorithm for multiple linear regression. Okay, in multiple linear regression, what we have multiple features, x1, x2 and y. Okay, so this is 0 1. Like suppose I'm doing a AND gate. For AND gate, so for AND gate 1 0 will be 0, 1 1 will be 1 and 0 0 will be 0. Okay, so this will be my input. Okay, input. What will be the dimension of this? What will be the dimension of this?
2-dimensional.
It's two dimensional. And what are the dimensions? Rows and columns?
4x2.
4 cross 2. Okay. And what about this y?
It is 1 dimension.
Uh-huh.
4 only.
We'll not say it is one dimension. We'll call it two dimension. Okay. If we are calling it as one dimension, no, then basically it is like this only: 0 0 1 0. It will not have. It will only have one dimension. 1 2 3 4. It will have only one dimension. But if I want it to have two dimension, okay, then I need to convert it into a 2D array. So I'll convert it like this. So this is a like very important concept. Like just try to understand this. Okay, like I also faced like a lot of problem in understanding this, but like it's pretty easy, not a difficult thing, but just try to understand this. The dimension of this would be 4 cross 1. Okay, if I'm storing it in a 1D array, then the dimension would be 4, but I need to store it into a 2D array so that its dimension become 4 cross 1. Correct? Okay, and what will be the dimension of the weights? What will be the dimension of the weights? See, what will be my equation? Let's see, what will be my final equation? What will be my y? Yeah, please tell, what will be my y? Y predicted? Yeah, come on, in linear, multiple linear regression, what used to happen? Okay, so for the first feature, there will be some value. Okay, suppose this is m1. Now this is m2 into x2 plus the bias. Okay, so we wrote the equation like this now: beta naught plus beta 1 into x1 plus beta 2 into x2. Correct? Okay. Now okay, now like if I write, okay, okay, so what I need to do, uh like how can I give you the example? Just give me 1 second. Suppose this is now 1 0. Okay, so suppose the first, see, we'll take every row. Okay, we'll take every row. Okay, what we need to do, we'll take every row and we'll have the weights. Suppose first the weights are 0 0. Okay, so we'll multiply these weights. Okay, so this is the actual final, this is the, this w, and this is the weight 1 and this is the weight 2. Like here we are using a m1 and m2. Okay, so what I'm trying to do, okay, what I'm trying to do, I'm trying to convert this, okay, into a matrix form. But like before going into the matrix form, like let me show you the code, okay, of gradient descent. So learning rate, iterations, number of points that I have. Okay, so like just try to understand this code. Okay, what I'm doing, the number of features that I have. Okay, okay, I'm trying to calculate a point between 1 to 6. Okay, and the number of features is 3 over here. Okay, so what it will do, it will create a 1D array, okay, of size 3. Now this 1D array of size 3, how many times I want to create? I want to create it 10 times. So that's why I ran another loop. Okay, so like this part is from comprehension. So just like, are you able to understand this statement, what this statement is doing? Or like, do you want me to explain this? Yeah, please tell. Are you able to understand this, what is happening over here? See, basically what I'm trying to do, okay, I'm trying to create an array. Okay, like I want to create like 2D matrix, okay, in which I want to have three random numbers, three random numbers, three random numbers. Okay, so I want to create a 1D array, okay, of three random numbers. So how will I do this using comprehensions? Okay, I'll write like this: for, okay, in range 3. Okay, and here I'll write np dot random dot randint. So this is the function that we saw. Now this is the starting and this is the ending value. Okay, between which terms I want to like find the random number. So okay, so this first array will be calculated using this. Okay, now what will I do? I want to create, okay, this type of array 3 times, this type of array 3 times. So for that I need to run another loop for in range. Okay, so this okay, this refers to total number of rows that I want. So I want 10 rows, so that's why I specified 10 over there. Okay, so like it may seem a little bit difficult, but just revise it. Okay, you will understand what is happening over here. Okay, so I have converted this array using this. Yeah, anyone, are you asking any question? Okay, see, now what I did, I created a 1D array. Okay, I created a 1D array using this. Now I need to convert that one. Now then I converted into a numpy array using this. Here what I'm doing, I'm converting this y from 1D array to a 2D array. Okay, what will be the dimension of this y? Like till here it is a 1D array, so what is the dimension of that array? What is the dimension of y?
4, sir. Only 4.
4.
Only 4.
Why 4?
Yeah, because
See how many points we are initializing over here. No? We are having 10 points. Okay, we are having 10 rows over here. No? So that's why the dimension of y will be, you are talking about this example.
yes, sir. Yes, sir.
Okay, okay. Here though it is 4. Here though it is 4, but here it is 10. Okay, here I have specified it as 10. So here the dimension of this y is 10. Okay, so I am converting this, okay, to a 2D array. I guess I'll show you. Okay, that will make more sense. I'll okay, so this thing though you don't need to see. Okay, I'll show you the value of y when it is here. Okay, when it is an array. Okay, 1D array, and I'll show you the value of y when it is a 2D array. See, here it is a 1D array, here it is a 2D array. Okay, what is the dimension of this array? What is the dimension of this array? Yeah, please tell, what is the dimension of this?
2 dimension.
2 dimension. This array, this array. This is not 2 dimension. This is the 1 dimension because we only have one bracket now over here. So
Sir, 10 comma,
10 comma.
that's it, because it is only 1D.
It's 10, not 10 comma. Okay, there is no need to write like comma. Okay, comma will be used when we are specifying this 2D matrix. Okay, so for this, what will be the dimension for this array? Okay, so how many number of rows we have? 1, 2. Okay, 10 rows are there, and inside
10
each row,
come out.
inside each row, how many numbers? Only 1. So 10 into 1. So that's why I, okay, did like this. Same I'll do with the weights. Okay, so I'll the weights will be the number of features that I have. Okay, and okay, I'll convert this 1D array into a 2D array using the same. Okay, that I'll these weights will be 0 initially. Okay, and bias is also 0. Okay, so this so you can see the shape of the weights, shape of x 10 cross 3. All right, and like just forget this part for now. Now suppose I want to multiply this weight into x. So how will I multiply? Okay, so the dimension of okay, so just ignore this part, just ignore this part, it will create problem. Okay, so I am calculating my y predicted. So what I am doing, I'm multiplying x into w plus bias. Okay, so like this is pretty simple. This is my prediction, and this is the cost. Okay, so the cost is same that I told you. Y like you can use both. Okay, y minus y predicted or y predicted minus y, because here we are squaring this term, no? So that's why it doesn't matter, but it will matter over here. Okay, it will matter over here. So okay, now can you tell me, one second, there is some problem with this code. It should be y minus y predicted, no? Okay, it should be y minus y predicted. Let's try to, okay, y minus y predicted. Y is the actual value and y predicted is the predicted one. So let's change this and then see what happens. Okay, 1 second. Okay, 1 second, 1 second. This is correct, this is correct. Here so I can write y minus y predicted. Okay, here I can write. Now tell me why this is correct. I was using y minus y predicted over here, no? But here I am using y predicted minus y. Like if you see the equation that I gave you, no? See, what was I doing? Y minus y predicted I am using. Okay, actual y and the predicted y. But here I have written y predicted minus y. Why is like that? Okay, so like what I have done, I have taken the minus sign inside. Okay, so that's why this thing is becoming confusing. Okay, what I did, I took this minus side inside, so then it will become y predicted minus y. Okay, so that's why. So like I should not make this complicated, but it became complicated. Okay, so that's why I have written y predicted minus y. Okay, this minus sign that was there, no, I like put it over here, and same thing I did for the biases. Okay, then I'll use the same like equation for updating the weights and bias. Okay, now let's run this code. Okay, so these are the arrays that I have. I'll run the gradient descent algorithm. Okay, and like this is my mean square error. Okay, finally that I got. Okay, so I can use these libraries for finding this, and also I can find the r square value and see. Okay, this is the like the error that we get. So you are seeing that the error is very high. Okay, the error is very high as the iterations are increasing. Okay, so what will I do? I'll try to uh, increase my learning rate, then we'll see whether the error is going down or not. Okay, let's see. Yeah, it is coming down. It is coming down. You can see that if I increased my learning rate, okay, my error came down for the same number of iterations. Okay, now let me increase the number of iterations. Now I'll make it as 1000. Now let's see what will happen. So you can see that the error is not reducing after a certain point. Okay, so in this case, like this would be the minimum error that we can get. Okay, so like this is the thing that would have happened. So okay, so yeah, like time is also over, so let's try to reduce this and maybe increase this value. Okay, now let's see. Yeah, see, if I use the like appropriate learning rate, then I'm able to reduce my error much better. Okay, so like just try to understand the importance of this learning rate that is there. Okay, like there is one more thing I wanted to tell you, because I was thinking that I should finish this derivation part of this linear regression. Okay, um, like what do you want, that should I continue, like it will take 15 minutes, or do you want that we should discuss tomorrow? Yeah, please tell. Do you want me to discuss like the other part of this? Like we have done our this, okay, gradient descent, okay, in some multiple linear regression, but there is one more thing I wanted to tell you. Or do you want to study tomorrow? Just tell, right now or tomorrow?
Tomorrow.
Tomorrow. Okay, okay. Okay, so like you better like revise all these things. Okay, so this notebook I've already shared with you, so try to revise this. Okay, and just play with these values that I told you, that learning rate, okay, and the number of iterations. Okay, if we change this, then how my algorithm will converge. Okay, how will it converge? Okay, all right. So that would be it in this session. Thank you all for participating, and we'll be meeting tomorrow. Okay, so till then, bye bye everyone.